Hi, welcome everyone to this start of a playlist or a series of videos, hopefully 3 videos, about an hour each. And this is going to be making the Asteroids game in JavaScript. And in actual fact, we've already done this on this channel. In fact, it was the very first playlist that I did. If we go to my channel here, and we go to playlists and we go to Asteroids with P5 and Vue.js, and in here we went through 5 videos where we set up the P5 graphics library, Vue.js as a front-end JavaScript library, and then we wrote the game in JavaScript. To be honest though, I've been wanting to change it pretty much since when I did it, because it was when I first did it, I immediately tried to do live streaming, and there was issues with latency and lag and all kinds of other stuff. So I wasn't. It was a bit of a train wreck, to be honest. So I've always wanted to redo this, but I wanted to get a few other videos under my belt first before I come back to it. So we are going to redo this in 3 videos. So that's the introduction for this playlist. Is we're going to do Asteroids.js, but it's going to be a lot cleaner. We'll learn a few lessons from the old one that we're not going to do. So just before we start properly, I already tried this a couple of days ago and everything was fine. Wrote all the code. In fact, I have the folder. This was the original one that we did last year in this rocks folder. So you can see we have the Vue.js structure, import and everything in. And then just the other day I decided to do this, exactly what I'm trying to do now, except I'd bought a new headset from Amazon, and to be honest, it was terrible. The microphone was terrible, but it hadn't realised that properly until I did the recording and played it back. And as much as I had all the video and all the code, the audio was horrific, so I just couldn't use it. So I'm doing it again. I've gone back to my webcam mic, so the microphone is actually in this webcam here that I'm using, and it's been adequate for the last few months for the other videos, so we're going to stick with that. So what that means is, if I close all these, it means that we're going to set up a new folder here. We'll call it Rocks 3, and then we'll get started. So let's begin. Video 1, Rocks, basically Asteroids in JavaScript 101. Okay, so as we said, we're going to create a new folder first of all. So we'll bring up the folder where it is. So this is my YouTube folder, and you can see I have Rocks and Rocks 2. I also started the massively multiplayer versions of this game, but they're ongoing. I wanted to come back to this and clear this up. So what we'll do is we'll just create a new folder called Rocks 3, because I have no imagination. We'll start in there. So let's take him away, and then in here I'm going to add folder to workspace, and hopefully I can just add Rocks 3. There we go. Now, to make things a bit easier, because I've already done this now, I'm just going to copy a load of stuff from Rocks 2, but we'll go through it sort of on a line by line basis, just so that we know what we're doing. So the first thing we need to do is create this index HTML file. So let's go into Rocks 3, new file, index.html. Now, if you're in VS Code or some other editors, they have some great shortcuts to write a load of stuff very easily. I think PHP Storm does it, maybe Atom does it. It's called snippets. I think they're called snippets. So basically, for example, if I type HTML:5 and then press enter, all this boilerplate code gets injected into the page for me, so I don't have to worry about the exactness of it or just the sheer length of it. It's all there. So that's that job done. So this is our index file that will be sent to the browser, but obviously our game is not really like a traditional web page, in that it's just a big graphics library, and we'll come to that in a minute. But we do need to add a few things into here to make the graphics system work. So you'll notice in the Rocks 2 we have this p5.min.js file. If you go to the p5 library, which you can get at p5js.org, go to, where are we, download, And then if you scroll down to single files, and I've just clicked that, and it goes into your download folder, and then you just copy it into your, just move it into this folder that we've just created. I won't do it now because all it does is download it. So once you've downloaded it, you can move it into your file. So what I'm going to do is just copy it from the Rocks2 folder, paste it into there. So now in the Rocks3 folder I should have, there we go, p5.min.js, but we need to reference it in our index file. So we can do a script. In fact, we could do another snippet here, I think. So if I do scr and then colon, if I do script colon source or src, all we have to actually do now is type in the path to the file. Now the file is in the same folder as the index file, so any file in the same folder we just do /, which means in this folder. And it already knows that we mean that because the IntelliSense of VS Code says, well, if you're in this folder, you either want index.html or p5.min.js. Now, because we obviously don't want ourselves, as in the file, the index file, so we can just click that, and there we go. So it's now brought in the p5 library. Now, one of the things when we ran it under the view system in Rocks, because we ran it under view, that means we had, if you followed along with that, we had a package.json file, which means we could run it under the save, npm run save, in order to act as a website. But we're not doing that here. So the easiest way to do this, on the Mac at least, and I think you can do this on Windows as well, is to run a Python server. And as I said, you've got Python, which I think, well, I know Mac comes with it as standard, and I don't know if Windows does, but there might be an alternative to Windows that does this that I'm not familiar with. But basically, we just type in Python -m -m simple HTML server, and then we want to put on the port number. I'm going to pick 8082, and we now have a website on localhost 8082. Now the reason why I picked that number is I've got the original one on 8080, the one I did the other day on 8081, just for a reference. So this one is now going to be localhost 8082. Okay. Why has that done that? Ah, right, I haven't done it in the folder of, I've just done it in the folder of my website. It's brilliant, isn't it? I've done it just on any random folder on my computer. So what I need to do is actually go to the folder where my website is. Set volumes, data1, YouTube, Rocks3. Now if I run the server on 8082, there we go. So we have no errors, but we have nothing at all. Yeah, so that's excellent. That means the web server's work, and we can work with that. Good. So, so we need to bring in the script now to run our P5 stuff. So in the Rocks2 folder, we had this sketch.js, and it had our methods and functions. This is what I did the other day. So that's what we're going to do here. So let me just close all of these. So in our folder, new file, sketch.js. I just call it that because the guy I learned it from on the Coding Train YouTube channel, that's what he calls it. Now, if you followed any of the other videos, you'll know that Sketch has a number of lifecycle functions. In other words, functions that the P5 library knows what to do with them. And there's two in particular we're going to start with, but we're going to add a few more later on for interactivity and such. So let's get the two basic ones up and running, which is setup, and I'll explain these in a second. And the other one is function draw. Okay. Just a brief explanation, because we have gone over this before in some of the vids, but setup is run once at the time the page is loaded. So this allows us to sort of initialize things that we need, but we don't need to sort of keep changing. So it's just like a one-off thing. Whereas draw is ran every frame. Yeah? So in fact, let me just run this, put a little note in here. Every frame. Now a frame is every time the screen is redrawn. And when that is, how often that is largely dependent on how good the computer is. So if you've got a really fast computer, then it could be run up to 60, 70, 80 frames per second. If you've got a bit of a slower computer with not as good processor, it could be running at 30, 35 frames per second. Whatever that frame rate is, and you'll see it as an abbreviation, well, an acronym, FPS, frames per second. Whatever that is how many times this function is called. Okay, so that's going to have a bearing on how fast the game runs. Now, for single player games, it's not a big concern, but when you get into the multiplayer world, it becomes an issue because different computers can be running at different speeds. So it becomes more of an issue. But here it's not an issue. We just need to know it's something that's ran every time it finishes running, it goes back to the beginning of it and just runs it again. It just keeps running in a cycle like that. So let's get going. Now in this video, we've got 3 videos hopefully we're going to do this in. In this video we're going to get the ship class set up, so the movement of the ship. So if I take you back to the one I did the other day, so this movement of the ship, okay, so that's what we're looking to do, and also the angle that it relates to in relation to the mouse. Now on the original game, this worked the same, except I used the arrow keys, and in reality people don't use the arrow keys for movement of games, especially for this kind of game. So I did change it across to the WASD keys, which we'll do as well. So that's what we're going to do now. So if you notice on the one I did the other day, we had a classes folder and then I had the various things in there. So let's create a classes folder, just keeps it organized. And then in our classes folder, let's create ship.js. Now I've done it with a capital S for convention. I don't think it matters how you do it, but it's up to you. So class ship. Okay, so we're going to put in a constructor function, and a constructor function is basically what's ran automatically the first time the new object method is called. So this is the class, this is like the template for a ship, and the ship itself, when we create it, is an object instantiated from that class. And when we do that, when we create the ship object that we can use, it runs this method here. Okay, so we use this constructor as a way to set that up. So let me just save the sketch, and let me just check what I did in the, because I changed it and I had to think it through, and I don't want to have to think it through all again if I know what I'm doing now. So yeah, you'll notice in here we had a constructor and we had an X. Oh, that's the asteroid class. I don't want the asteroid class, I want the ship class. So the ship class has an X and a Y. So remember, we're dealing with it like a grid of X and Y coordinates. It starts at the top left of your page, and your Y coordinates increase as you go down, and your X coordinates increase as you go to the right. I don't know how you're seeing this on the video, but anyway, that's how it works. So the X and Y is the initial place where the ship is created. So in that one I did the other day, where did we create the ship? We did stuff with it there in the setup function. Okay, so let's just copy this line and go into our sketch file. Okay, so this was in the setup function. So ship. Now, because we're not saying let ship or const ship, it's assuming that this variable ship already must exist. Now, because we want to access the ship in any of the functions that we have, we're going to make it global within this P5 library. So that simply just means we go let ship. That's all we have to do here, outside of the functions. It now means that the ship object, when it will be an object, is now accessible in any of these functions that we run down here. We don't have to keep passing it about. There's a big topic on global variables. This isn't strictly like that because this is all within the P5 environment, but there is a thing about whether to not use global variables, and generally you wouldn't do that. Global means you set it in such a way that it's accessible from all the functions. But in this instance, it's fine because it's how the P5 system works, so I'm fine to do global variables here. So what we're saying here is let ship, which initializes it to something, but we haven't said what. Then here we say it's a new ship object based on the ship class that you saw earlier. But we pass in two parameters here separated by the comma. So the first one is width divided by 2, height divided by 2. Now the width and the height are P5 methods, which are the current width and height of the visible canvas that we've injected into our HTML page. Now as it happens, we haven't actually done that yet, and I've missed that step. I noticed it when I went into the other sketch before, so we'll just do that now. It's very quick. I was eager to get started with the ship class. But you'll notice here we have this create canvas, which is a P5 method again. So let's just copy this, put it at the beginning of our setup. Now, so what it's saying is we're going to create a canvas, which is a HTML5 thing that came out about 10 years ago. And it allows us to do all these fancy graphics. And it takes a window width, which is the actual visible width of your browser or whatever device you're using, and the window height, and then it sets that as something we can now use to do all our graphics on. Now don't worry about this -6. It was just when I didn't put that in, it just didn't render right. It was like overlapping and there were scroll bars. In fact, let me just show you. Let me take that out. So if I reload this now, oh yeah, it's not doing anything because we haven't imported the sketch file properly. So we've loaded the P5 library, but we haven't imported our own code. So let's just import sketch.js here. Reload that. Okay. So class ship is not defined, so we also need to import the ship class. Put that above actually. So we need to go into our classes folder and then ship. Okay. So no errors, but you notice there's this bit of a scroll that's appeared here. In fact, just to highlight this, I'm just going to put a background on here. Just going to put a black background on here so it's contrast. So there, you can see when I scroll and it goes up, and then I can scroll to the right, and you lose this left margin and so on. It was a bit iffy. Anyway, there's a couple of things we just need to do to tidy this up. You'll notice in the one I did the other day we had this style method, not method at all, style attribute in the head, and it just zeroes out the margin and the padding so we can get as closer to the edge as we can. So when we run this, so it's a lot better now. We've lost one of the scroll bars, but we've still got this other one on the right. It's as if it's just still too big and it's forcing this scroll bar to appear. So that's when I did a bit of experimenting and just put a -6 here. And if we run that, we have a little bit of a white lip there at the bottom, but generally there's no scroll and it fits absolutely mint. So we'll stick with that. So that's our canvas now, and we've actually put a black background on, which is great because we need to do that for the game. And we've initialized our ship, but we're not doing anything with it yet. So we need to draw our ship. So let's do that here. We can do that quite simply by saying ship.show. Ooh, how easy was that? Run that, and obviously we're going to get an error because although we've set a reference to ship.show, it knows nothing about that. Ship.show doesn't exist. We've just said, right, run this function, but there is no function called show. There's no built-in function that does this. And even if there was, how would it know how to draw our ship? So basically what we're saying is we now need to define what this show function does for the ship. So in our oh, we didn't finish off our constructor, did we? Let's just do that. So in our constructor we passed the starting position as an X and a Y coordinate. So we can just pass that in as X and Y, and then we can just not let, because we're inside the class. It's now this dot position equals create vector. Now create vector is a P5 method that gives us a great way of working with the coordinates on a grid so that we can move stuff around and use great methods to make it a better game for us, different features. So that just gives us a position, that's fine. And what we'll do now is just create a show method. So ship.prototype.show equals function. Now for now, just to get a reference, we're just going to draw a circle. So we just say LLI ellipse at this.x or this.position.x, this.position.y. I think we'll just do a 2020 wide. I think that's how it works. So we go back to the sketch, and we've got ship.show. Should work. Let's have a look. Ellipse is not defined. So yeah, that's the 3L variant, which I sometimes use but doesn't work. So there we are. We have no errors, but doesn't seem to be anything on our screen. So I think that is because we need to set the stroke. Oh, not this again. I've got this stupid library in my VS Code that has absolutely nothing to do with what I want. So I'm going to set the stroke to white, which is 255. And again, I'm not seeing anything. Okay. Oh, I draw the ship and then I draw the background, which overwrites the ship. There we go. So that was width divided by 2, which is in the middle, height divided by 2, which is in the middle. So there is our ship. It doesn't do anything, it's just there. Now, the problem with oh, excuse me, just a bit of a dry throat. The problem with having it in the setup though is that this is only going to run once. So even once the ship coordinates move, this, the way it's set up at the minute, is never going to reflect this. So we'll see that in a minute. I'll deliberately make it like this so that you can see why we have to change it. But for now, we have something that resembles a ship. Okay, so let's put some false movement in here. So every frame, let's change the ship position. So let's do a ship dot move, and we're either going to say move in the X direction or in the Y direction. So actually, let's just move it in the X direction by 1 and in the Y direction by 0. That's all we need for the minute, because this is just us messing around. But ship doesn't have a move method, so again we have to create this. So let's go to our ship class. Let me put it before the show. I like the show at the end because that's like the finished product. So ship dot, although that's just my preference, you can put it wherever you want. So ship dot move X and Y equals function. Okay. So we want to alter. So let's create a vector for the movement. So this dot what do we call that? What did I call that in the other one? Velocity. Velocity. So this dot velocity, in other words, the direction, so a vector basically, but we'll call it velocity. This dot velocity equals create vector and it's going to be x, y. So this velocity is now equal to one of 8 positions, depending on whether the, you've got like with a combination of up, down, left, right, you can go in 8 different directions. So then we say this dot location dot add. So this is one of the beauties of having it as a vector. You can just say, you can add to the location this dot velocity. And x is not defined. Oh, put them in the wrong place, haven't I? So get rid of that. Put them in there. That's the one. Cannot read property add of undefined. So that's this. Oh, position, not location. Okay, so no errors, but nothing's happening. Nothing's happening, and yet, if I console.log out this dot position, remember this is every frame, you can see the x coordinate is increasing all the time, but the y is staying where it was. So even though the x coordinate is increasing, and that should be going further across to the right, it's not moving, and that's simply because in our sketch these show methods we've just left in here. So what we need to do is move that into the draw so that it redraws it every frame as well. And there we go. So there we have a moving ship, but you notice it's leaving a trail of itself, and that's because we're not redrawing the background every time. So again, if we move this, so it means every frame, clear the background out, make it black, and then do all our drawings. At the end of that frame, go back to the beginning, clear the background out, things will have moved, so then we redraw it, and that gives us the illusion of animation. So now, basically in slow motion, it's drawing the black frame, drawing the ship, altering where the ship is, drawing it, going back to the beginning, drawing the black frame, moving where the ship is, drawing the ship, going back to the beginning. But if you do that very, very quickly, you get this animation effect. So that's cool. So we can take out that movement, we know that all that works. So we can take out that console log, and I think, was it here? Yeah, the ship.move. The ship.move is obviously going to be dependent on interaction by the player. So let's do that now. Now this is a little bit tricky, so I am going to have a look at the one I did the other day. Okay, so the only difference here with this ship move class is I put this multi in, and all that is it multiplies the size of the velocity, the size of the vector, so that it moves at, in this case, twice as much as 1 pixel, so it's going to move at 2 pixels. And the reason I've left it like this, rather than just putting a 2 in, hard coding it for the movement, is that a ship, when we go into like the multiplayer mode, or if you pick up even upgrades in this game, or the power-ups or whatever it is, we could have some kind of separate function that looks at that and sees whether any of the upgrades merit the ship to move more. So this could actually be quite an involved function that applies the upgrades to the ship and multiplies it by whatever the resulting figure is. For now, we're just going to hard code it to 2. So let's just copy that line across. But again, that's something we could very easily implement later now, because it's just there as one line that we can add in. So what that means is our ship moves a bit faster, or twice as fast. Oh no, we took out the feature, didn't we? But anyway, so our ship will move twice as fast. So the other thing we need to do now is capture the key press for the ship to move. So what we do this with this function here, which is capture key press. Now I am going to copy this, but we will explain it out. So that goes into our sketch folder. Okay, so we set the X move position to 0 and the Y to 0. So we need to think about this. We've got our X position, which is along, left and right, and our Y position, which is up and down. Now remember we said that the 0, 0 starts at the top left corner of the canvas. So anything that comes to the right of that is going to be a plus figure, and anything that goes to the left of that is going to be a minus figure. And with the Y, it's going to be a plus figure for down and a minus figure for up. So if we have an X move of 0, that means this time round add 0 to its current X location. So in other words, don't move it, just leave it where it is. Same for the Y. But if the X move or the Y move was 1, let's say the X move was 1, that means go in the direction of to the right, because 1 is a plus number and we said X goes plus to the right. We're not bothered about how much, as we said a minute ago, we're going to leave that to the class itself to work out how much it moves based on upgrades and dynamics of the game. What this is doing, the key press is simply determining which direction to send the ship in. So a 1 means send it to the right, a -1 means send it to the left. For the Y, a 1 means go down, a -1 means go up. Okay. So here we capture the 4 different possible key presses. So you've got the A, D, W and S. So A, D for left and right, W and S for up and down. So these are the key codes for each one of them, 65, 68, 87, 83. And so you'll notice that I set either the X move value to 1 or -1 and the Y move value to 1 or -1, depending on which key or combination of keys is pressed. So if A and W are pressed, then that's going to be -1 on the X and -1 on the Y. So it's going to go -1 that way, -1 that way. The resultant direction is the diagonal effect like that, which is obviously what you'd expect if you press A and W. So once we've got all them, we then call the ship.move class with the X move and the Y move. So depending on which keys are pressed, it's going to determine whether each of these are either a 0, a +1 or a -1. So then that gets passed into this move class in the ship, if it's a 0, +1 or -1. And here is where we multiply by the speed we want it to go finally, which is 2 in that direction. And then we add that to the current position of the ship. And then later on in the same cycle, the show function will be called and the ship is drawn. So let's go back to our sketch. So that's fine. We just haven't implemented the function at the end of our draw. So now if I run this, nothing will happen, nothing will change. Even if I press the keys, nothing happens because this function is just a standalone function, it's never been called. So what we need to do is capture the movement here. So we can say capture key press, call that function. So now when we run it and we press the keys, here we go. So I press S, A and W, there's our diagonal that we just discussed. So any combination of the up, down and left, right gives us our movement. And obviously if we go back to these games, that's where we get this movement from. So that's excellent, we've got our movement in place now. So the other two things we need to do is we need to get it to line up to our arrow in direction. We also need to actually draw it as a triangle. So we'll do the triangle bit first. So all that basically means is we just sort of give it a fancy show function with a few extra bits in it. There's nothing too complex. So we go to our ship class here and go to show. So you'll see well actually this sets the angle and the triangle at the same time. So let's just do it one bit at a time. So we need to put a push in and then the translate to the current position. So let's go to our ship. Okay, so let's just comment out that ellipse. So we need to put a push in which means we need to put a pop in. And push and pop basically means anything inside this code that affects coordinates or positions doesn't spill over into future code. It's like encapsulated inside the bubble. We can mess with it here, and then when it gets to pop, it just undoes all that, any references, so that it doesn't interfere with any of the other code. And you're going to see why that's important. So we need to use this method here, which is a P5 method called, it's in caps lock, called translate. And the translate takes two arguments, which is an x and a y. So what this does is, at the minute, position x and position y of the ship could be anywhere on the screen, anywhere within the canvas grid that we've set up. But just to make it easier for us, by doing translate, what we're saying is, well, make the ship position now 0, 0. So anything we do from now on, the ship will be treated as 0, 0, not the corner of the screen, but where the ship is. And that means we can draw the complex shape of a triangle without having to factor in the position on the screen for every single coordinate. We can just treat it as everything referenced to 0. When we've done all that and we've drawn the triangle, we can then pop it, and that will pop the 0, 0 back to the way it was at the beginning, which is in the corner. So that's why we have the push pop and why we use the translate. So we need to draw the triangle now. Let me just have a look at oh no, so the next thing we need to do is, let me copy this line because it's quite long. So this is to get the angle of the ship. So if we go to here, this one, it follows the mouse, and this one, it follows the mouse. So that's what this, at the minute we've just got a circle, so it's not even going to be obvious. But we've commented out the ellipse, so we'll be drawing the triangle in a moment. So we need to set this angle, so which means we need to, let's just set it to 0 to begin with, but obviously we're going to pass in this on every frame draw. So this angle equals, now this a tan 2 is a P5 method. It's worth looking at. ATAN2. So you notice here in the sample, you can see it following where my mouse is, and that's great. That's just, makes it so much easier for referencing. So what we're saying is ATAN2 mouse y minus this position y, because remember, although we've zeroed the ship to 0, 0, the mouse will always use the global variable of where it is on the screen, because it's always referenced to the screen. It's just the ship that we've pocketed into this bubble. So we take the current mouse position but take off the current position of the ship, and the same with the x position. We take the current mouse position, take off the position of the ship, and that will give us the corresponding angle that we need to point the ship in, to point towards the mouse. Okay, so let's see what else was in here. So yeah, so now if we just let's draw the triangle, and we'll come back to all these other bits in a moment. So in the ship class, okay, so this is us drawing the triangle. Triangle is a P5 method again. So we start at 0, the first point. So basically we could do an XY for each of the 3 points of the triangle. So we have XY for that, XY for that, XY for that. So we've got minus radius, 0 minus radius, so it's going to be, you can imagine the ship's there, the triangle. 0 is at the middle of the ship, so the x is 0, so we're staying in the middle that way, but we'll go minus radius on the y. Now minus is up, so we're going to go up that amount. That's the first point there. The second point is the radius divided by 2 on the x, and it's a plus, so we're going to go half that way, and then it's the radius on the y, so half that way, a full radius that way. And then the third point is half the radius that way on the x, and again y, and that gives us our 1, 2, 3. That 1, 2, 3. That gives us our 3 points of the triangle. So this triangle, that's where our triangle method comes from, how it draws our ship. Let's see if that if we're up to date with that. Okay, I suspect this is it is there, but we just need to put a stroke. No, we have a stroke in there. We have a stroke in there. What have I missed? We haven't rotated it yet. We set the stroke. We set the stroke weight. We set the fill. Now the only difference is that I put the stroke inside the push, but I didn't think that would affect. But I'll put it in just to be sure. No, so that hasn't affected that. So let's give it a fill of. Let's give it a fill of. Oh my goodness, I need to change this. Let's give it a fill of white for now, but we will make it black with a white outline. No, so it's not drawing that. So, is it drawing it when I put the ellipse on there? It is. Triangle. Have I missed something from drawing the triangle? It's only the rotation that we haven't done yet, but all that means is that it shouldn't rotate, it should still draw. So what have I missed? We've got a stroke of white, a fill of white. Okay. So if I put that inside the translate, I should be able to set that to 0, 0, because now that should be in the same place, and it is. So the translation is working, but the triangle isn't working. Oh, I haven't set the radius. So let's set it to say 20 to get rid of that ellipse. There we go. So there's our ship. Now let's give it a fill of black. Yeah, there we go, that's better. So we have our ship. Obviously it's not moving, so we need to put that angle, and we need to put the rotation of the angle in. So we just rotate. Let's copy this line. So where did we put it in relation to everything else? Once we've got the angle. So once we've got the angle, we rotate it by that angle. Now you'll notice that we add pi over 2. In P5 library terms, we're measuring in radians, the angles, not degrees, and that means that a circle is actually 2 pi, which means half a circle is pi, quarter circle is pi divided by 2. And because this started at like that angle, we needed to add that onto the rotation value to get the proper value of the rotation. So that's all that was, like a calibration thing. So now, here we are. Every time it's being redrawn facing the arrow. So we have that, we have our movement, and even when we move, not a problem at all, following our arrow. So that's excellent. I think we'll stop this first video here. We've certainly done enough to get the ship where we want it, and in the next video we'll look at setting up the shots that come from the ship, and sort of eventually we'll be dealing with collision detection with the asteroids and so on. But we've done enough here for this video, so please, if you like this kind of stuff and you want to see more of this kind of stuff, click the subscribe button. I'm more than happy to keep generating this. If you like this particular video, please press the like button. It means an awful lot. It tells me I'm doing the right thing, and you know, people are interested in it, and I really do appreciate people watching these videos. So please look out for video 2, and for now, thank you.